Welcome back to another edition of The Explainer. Okay, I am absolutely thrilled about today's topic because we're tackling something huge. It's one of those massive, ubiquitous technological shifts that somehow still gets misunderstood all the time: cloud computing. Look, whether you're a total beginner just trying to figure out where your smartphone photos actually live, or you're a seasoned systems architect hunting for rigorous deployment frameworks, this explainer is 100% built for you. We're going to take a scaffolded journey together. That means we'll start with the absolute bare bones basics and then rapidly build our way up to some really advanced real-world deployment strategies. Let's get right into it. Here's our quick roadmap for the journey today. First, decoding cloud computing. Second, inside cloud architecture. Third, the 3 service models. Fourth, choosing your cloud strategy. Fifth, real-world applications. And finally, number 6, cloud security. Starting off with Section 1, decoding cloud computing. To get us grounded, we're actually going to look at the official definition from NIST, the National Institute of Standards and Technology. They describe cloud computing as a system offering widespread, on-demand network access to a flexible set of computing resources with minimal administrative overhead. Now, what does all that jargon actually mean for us? Well, first off, it means the cloud is definitely not an actual cloud in the sky. It's really a massive physical network of shared servers, dynamically allocating resources from data centers all around the world. So instead of running heavy programs on your own computer's local hard drive, you're tapping into serious computing power, storage, and networking directly over the internet. And this right here brilliantly highlights the massive paradigm shift we've all gone through. Think about traditional computing for a second. You had to buy super expensive hardware up front, you relied entirely on local storage, and you had to deal with really tedious manual setups and clunky recovery processes. It was just so capital intensive. But cloud computing? It flips the script entirely. Now you're using external servers with highly scalable capacity, totally automated backups, and flexible resources. And the best part, the real game changer, is the pay-as-you-go model. You go from shelling out cash for heavy hardware you might not fully use to simply renting automated scalable power exactly when you need it and only for as long as you actually use it. Moving right along to Section 2, inside cloud architecture. So let's look under the hood for a minute. It's fascinating how cloud architecture splits perfectly into 2 distinct halves, all connected by the internet. Over on the left side, you've got the front end. That's the user-facing stuff, the client infrastructure like the web browser or mobile app you're using right now. But over on the right, that's the heavy lifting backend. And honestly, this is where the real magic happens. The backend manages the virtualized hardware, the runtime environments, vast storage systems, and all those absolutely crucial management and security layers. It's the backend that guarantees when you click a simple button on the front end, massive computational power fires up in response instantly. Now, for the system architects tuning in, here is a fundamental design secret behind why the cloud is just so incredibly fast. On the left side, you'll see that cloud environments are what we call stateless. They deliberately don't maintain user session data on any single server, which is what gives them that incredible elasticity. And then over on the right, they use lightweight REST APIs for seamless communication with external services. Since every single request packs in all the necessary details to be processed completely independently, cloud apps can scale horizontally across hundreds or even thousands of servers without missing a beat. Pretty amazing, right? All right, Section 3, the 3 service models. This brings us to the ultimate question for literally any business migrating to the cloud. How do you choose between IaaS, PaaS, and SaaS? I know, these acronyms, infrastructure, platform, and software as a service, can seem totally intimidating at first glance, but don't sweat it. We are going to make this incredibly easy to grasp by using a really simple and honestly pretty delicious analogy. Okay, let's imagine for a second you want to open up a pizza shop. If you choose IaaS, infrastructure as a service, it's essentially like renting a completely empty building. The provider gives you the physical 4 walls, sure, but you have to buy all your own ovens, the tables, the ingredients, the whole shebang. You are building it completely from the ground up. Now, if you step up to PaaS, platform as a service, that's more like renting a fully equipped commercial kitchen. The ovens and the professional tools, they're already there and managed for you. You just show up with your recipe and your ingredients and get straight to cooking. And finally, SaaS, software as a service. This is like simply ordering pizza delivery. You don't need a building, you don't need any equipment, and you definitely don't need to cook. The fully finished product just gets delivered right to your door, perfectly ready to eat. So what's the big takeaway here? It's all about that classic inverse relationship between the level of control you keep and the ease of use the vendor provides. IaaS offers you the maximum amount of control and absolute flexibility. It's heavily targeted at IT admins who really want full command over the operating system. But keep in mind, it requires deep technical chops. PaaS sits comfortably right in the middle. It's an absolute dream for developers who just want to write code without losing sleep over server maintenance. And then there's SaaS. This targets everyday end users who want zero administrative headaches and are totally fine trading away underlying control for a polished, ready-to-use product right out of the box. To make this completely concrete, let's map these theoretical models directly to the actual industry heavyweights. For IaaS, you're looking at foundational compute power. Think Amazon EC2, Google Compute Engine, or Microsoft Azure virtual machines. Stepping into PaaS, where developers actually build their apps, we've got platforms like Google App Engine and AWS Elastic Beanstalk. And for SaaS, well, these are the apps you're probably using every single day. Google Drive, Microsoft 365, Dropbox, Salesforce. It is the exact same underlying cloud concept, just packaged in 3 totally different ways, depending entirely on what you need to get done. Next up, Section 4, choosing your cloud strategy. Making these deployment decisions essentially boils down to a highly actionable binary strategy. The very first thing a business has to ask is, do we want maximum control and do we want to build everything from scratch? If the answer is yes, boom, you go straight down the IaaS path. If no, you ask a second question. Do we want to develop apps really quickly without managing the underlying servers? If you've got a dev team eager to write code, you choose PaaS. But if you just need a tool that your workforce can use right this second, you bypass development completely and just choose SaaS. It's a beautifully simple binary decision matrix that perfectly aligns your technology choices with your actual business capabilities. Now, for the system architects listening, when you do commit to that IaaS path, pay close attention to how the big 3 providers achieve the exact same goals but use highly proprietary terminology. Take auto-scaling, for instance. Amazon adds or removes resources automatically. Google specifically uses its auto-scaler. And Azure grows or shrinks VM groups. When you need to balance traffic, you're deciding between AWS's Elastic Load Balancer, Google's Cloud Load Balancing, or the Azure Load Balancer. And for storage, your data is either going to rest in an Elastic Block Store, a persistent disk, or Azure's managed disks. Honestly, mastering this specific vocabulary is absolutely essential if you're working on any multi-cloud deployments. All right, let's jump to Section 5, Real-World Cloud Applications. It is so wild to see how the exact same foundational technology can simultaneously power vastly different sectors. Just look at this. On the left, massive cloud resources are managing intelligent transport systems. We're talking about secure APIs processing millions of geolocation points every single second just to manage ride-sharing logistics and monitor global traffic flow in real time. Then on the right, that exact same scalability and global accessibility is what makes modern education happen. It's powering massive learning management systems and virtual classrooms that anyone can access from anywhere. The cloud provides the raw computing muscle, but how you apply it, that's literally limitless. A perfect real-world example of this is in the manufacturing industry, specifically looking at the Siemens Smart Factory. They use cloud-enabled industrial IoT to build this massive network-centric infrastructure. We are talking about literally thousands of factory machines, all completely decked out with sensors that are continuously pinging data on temperature, vibration, pressure, you name it. All of this massive data stream gets beamed up to their MindSphere cloud platform, which runs intense real-time analytics. Because of this, the cloud can actually predict a machine failure before it even happens. It turns incredibly costly reactive repairs into totally proactive maintenance. It's a total game changer. And that brings us to our final section, Section 6, Cloud Security and Responsibility. Listen, if you only take one single thing away from today's explainer, please let it be this principle right here, the shared responsibility model. It's absolutely crucial. Cloud providers, like Amazon, Google, and Microsoft, they are responsible for securing the physical infrastructure. They lock down the actual data centers and the physical server hardware. But moving your stuff to the cloud absolutely does not let you off the hook. You as the business or user are still entirely responsible for securing your own data, correctly configuring your applications, and strictly managing your identity and access policies. Yes, the cloud is an incredibly secure platform, but how you choose to use it dictates how safe your data actually is at the end of the day. Which leaves us with a pretty provocative final thought. As we've explored today, the cloud is way past being just a trendy IT buzzword. It is literally the fundamental utility powering our entire modern world, from predicting those machine failures in smart factories to streaming global virtual classrooms. But as you personally embrace all this power and you inevitably push more and more of your digital life out onto the network, you have to ask yourself, Have you actually managed your end of that shared responsibility model? Is your data truly locked down and secure? Or is it honestly just resting unprotected on someone else's computer? Food for thought, right? Thank you so much for learning with me today, and I'll catch you in the next explainer.